Morning, top of the morning. Okay, it's noon. Maybe not top of the morning, whatever. Hello, welcome. We've got some updates. Let's see, I'm on page there. Okay, whatever. So, I'm looking at, maybe I should pull this over. I've been looking at this structure here, and I'm gonna do a little like introduction section here because there's a lot of information that is almost prerequisite knowledge to make sense of this, and I need to really like put it into perspective, because if I just start talking about it, I know how ridiculous it sounds and how easy to discredit it is. Okay, so let's just real quick, gotta go to my channel. This just is what it is. Play this. So this is my theory of everything and the subsequent physics discoveries that are in video format here, leading into the discovery of ancient Dwarka, leading into really a completely new model of geology based on Earth expansion and nuances that basically are that the Earth expanded where it was once a single landmass. A vortex weapon was used on this city, Dwarka, that then basically caused a storm, a runaway storm, like a hurricane, but that runs away and exponentially gets so energetic that it can't be stopped. The only way to stop it is for space itself to flow through it into the earth and to balance the system. And so it basically punctured the mantle. The storm itself sat here for a very long time, which I've talked about in especially my Mount Girnar videos, as well as here, but they're probably all in the Mount Girnar playlist because that's really focused on that region. But the storm sat there and it injected space ether particles and energy literally into the earth through especially this region that flowed down here in Pakistan physically to the mantle, that it then flowed into the mantle through the by puncturing the crust through so that the mantle could upwell, and exchange caused displacement of the mantle by space flowing into the earth and pushing the mantle out. And so it then flowed in all directions from the mantle puncture hole. And then the current flowing in all directions also was on a spinning globe. And so as those things occurred, the current got focused in the direction that the spinning globe encouraged, or it fanned out in the direction of westward, basically. In the westward direction, it fanned out underneath the crust, whereas in the eastward direction, it became more focused. So there's a fanning out propagation this way that then essentially over time the boundaries get shaped. Like, it's not exactly these boundaries initially. This flowed far further up here. It's just later pressures into this region pushed the boundary back to have basically an equilibrium between them and fill in and reshape this region as it is now. But at the time, it was probably more fanning out out further, presumably. But essentially, it reached North America, where it began to run into physical quantities of water sufficient to solidify the flowing mantle material, like basically like a basalt flow that is flowing, a large igneous province that flows like Mauna Loa flows kind of thing, not like explosive flows. But over here, once it reaches the water, it begins to solidify and have chunks within it, where then it basically produces a resistance to the current. So it ends up going around after it builds this, and this is occurring. It's building the region of Laurentia and moving across here. The current itself that's focusing across is basically building more resistance here until it has to go a little more this way. And when it starts to go this way, here, this region, this is what I've come to conclude recently and what we're inspecting. Although maybe I should go into more detail. There's also essentially this region, the current flowing out in all directions collides in this region, generally here. Although the moving collision, it's a moving collision where it's not just like perfectly balanced, like the balance moves across time depending on which current is more potent at collision points, because sometimes it's not like the full head-on collision versus a head-on like stream, so the more powerful stream in that area shapes the outcome. And there's just so much going on, but in essence, this region ends up being where this like ballooning occurs, because the currents are just getting kind of trapped there, so the only thing they can do is go up and down. And so that region is actually happening here, where there's currents like sawing up and down. And so what I've concluded is right here, this shape, which formed on top of this, all of this region, because this region was basically a current flowing that then produced its shape as it was able to produce an opening into resistance like this. And so this portion is at the boundary of the current here. Over here, if we look at the oceanic crustal age, over here it's much younger. It starts to really get into the like approaching 100. So this is really when things start to explode, is in this time frame. The blue is pre-explosion, pretty much. Pre-explosion is just kind of making pathways. It starts here from Dwarka, from the puncture hole. It flows this way, and then it begins to flow enough to like sever. And so it flows through here, but the ocean, Atlantic Ocean, is not yet formed. It's still a single landmass. It's just flowing down basically one little crack. Maybe I'll click this. Pardon me, I know sometimes I could make things bigger. Anyway, let's even go there. Okay, so it's flowing this way, and then it goes down this way, which is actually this way. Once this region fills up with pressure, it's not like instantaneous. Noticeably, there's even a substantial delay. Like these dates go by 10, but this one is like 100 million years, which is really in this frame, because this is able to open up, but then over here gets filled. So there's a time in that time frame where a lot of things are happening over here that are like because of the current flows that then lead into it over essentially around 100 to 80 million, it starts to branch down this way heavily. So it looks like there is a current even back to pretty much 180 that's flowing through here though, based on this. Around 180 it's flowing through the region and into right here. Like none of this exists, so just close it up because the earth is yet to expand. This blue is adjacent here, so this current flows into this. And basically begins to produce a space in the Earth's surface that opens, where within it is just a sheet of oceanic crust, basically, of this flowing magma that's solidifying, that's basalt, pretty much. So it's pretty much just oceanic crust that's not been differentiated, undifferentiated magma that's just been flowing without separation substantially, where it's just like oceanic crust. That's how I look at it. Pardon me, geologists who are like, I don't know if that's like offensive or whatever. Okay, so here though, the current is flowing up this way and then it's meeting resistance. So this is what I've concluded, is this region wasn't just like right here. Initially I thought it was sticking out here kind of thing. Now I realize it was starting down here and sticking up this way, where the dragon shape, this shape, was physically accumulating along this boundary. So I've made an animation. Before, it was more like this, where the boundary, the dragon goes up into the boundary, and then the current was flowing out this way. This is on a larger radius globe, so it's really not capturing precisely, but it's pretty, it's just pointing in the direction. I measured this, it measures well. I talked about this in my last video. I don't want to just like recap my last video points, but real quickly, this structure here appears to, when this is aligned, generally speaking, with that with this region, basically going through here. It's the nose goes to like the Baja BC, this portion. Wonder if it like, if it was down here. Or if it like slid out like here. It doesn't seem to, it does actually go right to the nose. It goes right to the nose, dudes. So it slid out that way. The nose physically slid up and out as it like moved on the pegs structure of motion that these things move on, like with peg type things, like a seamount, that formation that was there that moved up this way, and then the plate itself began to move especially out this way. So it must have like began to spread in a way that was causing that motion to occur until it reached a point where it could just dislodge out. Let's see, and then this point of it down here, seemingly related to this exit point, so the nose went out through this region. The, like, gut, I guess, through the Baja opening. That's the nose there. Central region, tail, which went up into the New Madrid fault zone and literally is the missing material. Like, this should be under New Madrid, but it's here because it was like pulled away with this structure that detached from adjacent here. So it physically slipped away here and here, probably because it was just carved by a current passing through that really severed it enough to make it so that when the chunk slid away, then the tail came with it. So there's this lacking support structure like that. That's really also maybe over here, but because it has other support structure where this came from, it's not as like detectable in causing earthquakes, etc. Whereas the New Madrid region where that section came from is really very little support structure, just this little thing right next to it. So it's kind of like on a pillar, but like because it's breaking, it's almost like sliding down, while this side is supported over this way. This side's just hanging out on the pillar, but then adjacent to it, next to the pillar over here, is a slab that's begun to physically slope because it's not actually atop the pillar, and it's separated enough where it's not as conjoined, basically. So like that aspect. Okay, I don't want to get into just like hypothesis without evidence. I'll be taking notes. This is what I got. Okay. So, referring again to the typical time frame of this, like time frame that matters in this region, like over here, the time is around 100 million years. Australia, 100 million years. We found some supervolcanoes in the right location there. Caribbeans all through 65 million, so like around 100, really even before 100, so like 120, 130, 150 even. I'm seeing sometimes things pushing a little higher, like there were some things going on as the pressure built up, but really like it began to run away exponentially around 100 million, and then like have like a main event where things broke and could freely float almost to an equilibrium around 65 million, where then like basically the bonds that were holding the structures together broke enough that they could, the space between could just be filled and the pressure could be relieved, and everything came to a much more stable equilibrium where these structures are just in their shapes and not changing really, and there's underlying the crust supporting it, so they're not even like inherently entirely filled with material. Like a good example is kind of like how this does. Support structure, pardon me, sir. This is from Myron Cook. Here, how it has like incomplete support structures to like a crust. This is basically what's going on. Is down below we got some support structure, and above we have the supported structure of continental crust. This is even reminiscent itself of the entirety of this region, how it has like almost like a tube thing. I feel like it's got structure of a similar nature involved, where this is like insightful to apply to it to a degree, where other places maybe not so much. Across the whole stretch of it, where it's like this column thing that has like a support structure that just is eroded away by undercurrents with a more dense supported material that then can like fall. Support structure, pillar. So like New Madrid is kind of like where this material is just not supported by that like node adjacent to, and then it's missing material, so it's much more like this. Like, hello, we're like living up here pretty much when relative to some like space that is not filled with relative density. It's not necessarily like literally empty like this. It could be like this material next to like a way denser material where like the effectively it just gets squashed and the space gets the pores within it basically get evacuated by the compression, and that causes like propagation throughout the system, but then it essentially collapses without even needing like a truly void space. Like even through like a system like this, just squash. Now the like above and below are more stable. Like it doesn't matter how strong it is, if there's enough force applied, it will like do that. So something like of that nature going on with New Madrid. But let's get into this data. Mid-Pacific Mountains, 100 to 110 million years. That's the initial data I was finding. So I was reading some of these papers. This one says about 110. Magnetic data indicate, at least in part. Okay. Must have originated over South Pacific superswell. So that's interesting. This region that is blue is the South Pacific superswell, where apparently there's like a up to 2 kilometers shallower, so it's more material of just a mound, a super swell, consisting of like large quantities of volcanic ash. Okay, mind you, I just mentioned the Earth was exploding, and here, let's go through some of these. It was exploding here, like there was a super volcano here going off that was shoving out this way. And then all this there was a current flowing this way that started to overwhelm and influence in a way where it just began to open this region. There's another current here, another current here, so there's 3 currents. Plus maybe even another, I'm not coming from this way, that I'm just like the Mariana Trench, now that I realize. Might have this here, the Mariana Trench, is caused by a current that's flowed from up here down through this way, down this way, this way, this way, and across here. So if we follow the Mariana Trench back and just follow the like lines back this way, I know it got. Sorry. That's right. It's better to start from up here because I get kind of lost looking at it. Coming through here, we can see this path pretty well. Then it cuts across here. It gets kind of lost in the noise. But I believe it just goes down here, and that's right to the Mariana Trench tip. So essentially there's a current here that's coming across here, across this way, and then essentially being counter to that one, while this current is coming in a different angle, and thus maybe that's the angle it was initially coming in, and it rotated. Like it was coming in that way, like this was across here, flowing in this direction basically, and colliding with this current flowing in here, causing it to basically one to go in, the other to go around. I've been just thinking it was here, 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 three currents, but that doesn't really have like a compacting force without this one to like hold it in place. So maybe that all of those are aspects of what's going on. It's unclear exactly when what was going on, but this was going underneath here. So this was here and just opening out and exploding. So like where the currents were colliding, exploding. And I believe it must have been in a way where like this, because Australia must, or was it? No. Pardon me. I'm trying to connect it to the Ammonite. Like, Ammonite was above it. But I think it just literally opened this hole over time as it pushed things apart and made space for this current to form without anything atop it, really. And so this current was forming without anything atop it over here, with the dragon forming here. That's the idea. Okay, so that means the explosion thing going on down here with regard to Baja, BC, and the things I've been talking about recently. Let's put it with Galapagos hotspot, the Caribbean. The energy is also putting a current generally like into this region. Up through here, interacting with this boundary, which is also interacting with a current, this current from the Mariana Trench, I guess. Not completely sure. Actually, this might be the path of things moving up this way and into here, moving the... This might actually be placing, like, this energy, this beam comes from, like, over here, goes over here, hits the dragon's nose, and then begins to move the nose this way, and also just create, like, a propagation of material from Baja, BC, from Baja, California, from this stretch, just propagating it from where this is meeting and interacting with all these other currents. So it's just this like focal point that then just sends waves through this way. Because they're below the mantle puncture hole, which is flowing a current this way. So when it goes through here, it goes down to this side and causes current this way, if anything. It's hard to say. It looks like it might have even just practically stopped. So, things that match. 110 million years. Must have originated over South Pacific superswell. So where this like explosion region is going on here, which was generally here before it moved away and new material accreted and formed this region, and more underneath support structures, new support structures formed that were more as they are today, I guess. Seems to be what happened. Like literally this came in afterwards and reshaped the region to as it is today. It's my thoughts in terms of the support structure that is below the continental crust, because initially it was, this region was over here but the continental crust was there. Like this opening in the Yucatan Peninsula, this gaping hole that exploded was certainly related to that. Right there was this structure going on. Which was over here. I know, guys. Okay, let's move on. Resolution Goyet. Was this at White Sands National Park? So I was kind of curious. I just wrote this down before we get to the data. This is called Resolution Goyet. This maybe is a good time to define what that is. A seamount with a flat top. This one, I believe. One of these up in this region. I'm pretty sure it's that one. That one looks the most like the images I saw. I didn't look that closely. But if the nose is here, I was kind of like, huh. It feels to me like if I look at this map and I know like the tail is over here, and that kind of comes like this. It's hard to say. Like maybe it goes down here, up here, up here, up, back down. It's like, could it be that this White Sands National Park is related? Let's look into it now. How old is White Sands National Park? Like, is it in the 100 to 80 million to maybe 70 million, but probably not later than that, earlier. More recent geology formation. Long ago. Began 280. Let's see, when did it end? Continues today. Okay. Whether or not it is, it would be interesting though. If this is where Resolution Goyet specifically was supporting that structure, and that moved away, whereas the nose was over here, so it's unclear what it was supporting, although it would be interesting if it was supporting Mount Stored, although that doesn't really resonate with this. Like, it's almost like it should be more of something like that if it was, if the salt region was in some way related. Also, there would probably be more of a continuous streak of them, more than one for sure. If there's these seamounts that are supporting, I mean, like that one's pretty flat. Although maybe there's something about it that would clear that up. Okay, let's move on. Prior to Barremian, through Barremian, so it's the formation of this Barremian period, prior to 129 million years radiometric dating, through the Jurassic. Perfect time. Okay, that's good. Horizontal movement from a position well south of the equator. So what I was just mentioning, it moved from over here to over here. I mean, maybe this was south of the equator. Like at that stage, or there was south of the equator. It's hard to say what the equator was. I've just been interpreting it initially as, my thought was that this was the equator here, and this was the equator, which then maybe like this would have been the equator and this would have been south of the equator at the time. I don't know where we put the equator relative to North America at that time. If like this is near the equator, I don't. New evidence on the geological prehistory of Texas. Find equator. Equatorial orbit would take us over an enlarged Pacific Ocean between the eastern shore of Asia and west. That's the only place it says equator. I don't want to look too closely at this. Where did Texas come from? That is a harder question, one that takes us back more than 1 million years in time and to far-flung parts of the world. To far-flung parts of the world. It is the bedrock we all see exposed in the Guadalupe and Chisos Mountains in the Colorado and the Brazos River valleys, in the ancient cliffs of the canyons along the Rio Grande and the shores of the highland lakes, and in the modern road cuts throughout the state that tells the story of Texas through time. That bedrock leads us back through a quarter of the history of the planet, and from southern North America, where we live directly, to 3 of the other 5 continents, South America, Africa, and even part of Antarctica, may all have been adjacent to what is now Texas at various times in the past. These former continental connections teach us about the enormous changes in geography in the global environment. I'm surprised they don't say Australia, but they say those. Like, I can see those. I'm just like, especially Africa makes sense. If this is where this current was coming in, then really this is like a widening section. I'm almost at the current induced. So maybe like Texas was much closer to Africa, so that makes sense. In terms of closed up here and then over here, like real close, maybe even this, I don't know, but this one had like, it had some space between. It had Australia between. I'm not sure Antarctica has any proximity to Texas at any point in the Earth's history. So that's a little surprising. So it's not that it wouldn't possibly bring materials and currents from there. It's just, and maybe it did go this way, up this way, and like a current that went through here, maybe it went like there and wrapped back around and came in and brought material that way, like that. I don't know how it, because I know there's a current that rips this way, rips apart South America and Antarctica, and then it goes between them this way. So maybe it did bring some material detectable back to Texas. It's still more likely in my mind we would be saying like Pacific Ocean islands and Australia, honestly. Let's see, Australia. Oddest to refine the paleogeography of the hypothetical supercontinent of Rodinia, aptly named from the Russian language as the parent of all subsequent continents. The Pacific Ocean formed between Antarctica and Australia on the one side. Okay, let's look up Rodinia. This might be a like plate tectonic map that shows the Pacific Ocean closed up pretty well. That's my guess. Is it actually? Like, this is way more like an expanding Earth model. Like, this captures things. Okay, so horizontal movement from a position well south of the equator. Plausible with regard to it being from that region. Site 463 near Resolution Goyet, which is the one I was just talking about, probably passed the equator around 72.1 to 66 million years ago. Which seems plausible again with everything. Displaced shallow water derived calcareous fossils from adjacent seamounts. So there's like displacement amongst the seamounts going on. So if there's currents just coming, bringing like current over here, swirling the things around, then there's likelihood of intermixing, of displacement, basically. Very sluggish water movements, early and mid-Cretaceous, as if this current of this like explosive thing going on over here, whatever's happening exactly, wasn't yet causing like back currents into this, but then around Cenozoic calcareous zones are, on the other hand, very condensed. Let's see if I can find maybe from this paper. I think it was this paper I was reading. Yeah. Right? Or no? This paper. This paper I was reading. Yeah, it was from this paper. Okay. Interrupted in many places by hiatuses pulsing in the like energetic propagations from this node that's just like rippling energy outward at times. Despite position well above carbonate compensation depth, where supply of calcite is less than solvation, meaning that there's erosion, overgrowth of carbonate deposition. Carbonate compensation depth, like below that line, it dissolves away. Despite position well above, show effects of dissolution and poor preservation, which, let's just say hypothetically, it formed adjacent here. It could have been at a significantly lower depth because it was held down under the weight of the continent as part of this like slab of underlying support structure that it was in part connected to, that was like holding it down under the crust, but then it basically like broke free, so it was no longer held by the undercrust, connected and conjoined to it, so it was able to like float, relatively speaking, and like be at its own equilibrium, which was at a much higher elevation. So there was a time perhaps whereas at a way below this number that I just said, the carbonate compensation depth. Okay. Frequency of reworked pelagic material with the hiatuses indicate episodes of intensive renewal, probably triggered by climatic deterioration of polar regions. So, like, there's certainly some explosiveness going on in the world that are triggering things of that nature. Put a star next to this one. Let's see how exciting this is. Most western Pacific oceanic plateaus are known to have a crust and early sedimentary sequence of the late Mesozoic age up to 66 million, and to have undergone considerable subsidence from earlier subaerial positions to their present water depths. So while this sheet was forming over here, it was forming adjacent to the continental crust, connected to the undercrust, but without water and with air flowing above it in a way where it has evidence that it formed in a subaerial climate and has since undergone considerable subsidence to their present water depths. The paper lists some rises that I wrote down. The Mid-Pacific Mountains Plateau is on Mesozoic oceanic crust. So this region is generally speaking Mesozoic oceanic crust. And it was perturbed by dramatic volcanic events in the Middle and Late Cretaceous. So that's just Mesozoic is like 250, 266, I believe. Yeah, 252 to 65. So it formed in the Mesozoic, which they would reference because it was forming earlier in the Mesozoic, especially. Like it's begun in the Mesozoic through 66, maybe. And then perturbed by dramatic volcanic events in the Middle and Late Cretaceous time. So they say that this region, these seamounts, are volcanic in nature. And I wrote down here, considered volcanic because some volcanic rocks dredged from sides and tops of the Goyets. So basically they're finding volcanic rocks in the region, but if there's some explosion over here, just shoving material over here, inclusive of its volcanic materials, and then depositing them in mounds along a boundary of resistance that takes a shape like this due to this current and then resistance from over here, then there would be volcanic rocks, especially found at the sides and tops. Like that would be, whereas volcanoes themselves are more like concentrated specifically. Like sides and tops is almost like it's a mixture mixed in, suggestive that it was mixed in by a current that mixed it in. Okay, so that's what I was thinking about that part. Extrusion of basalt and deposition of volcanic ash over wide areas, generating a bulge-shaped region of the Pacific floor up to 2 kilometers shallower than surroundings. The oldest sediments suggest volcanism in possibly the late Cretaceous, so around 150 million years. East-west segments strike northeast. So they basically, I noted this. The directions, no one's talking about his shape, and like this shape, I mean, they're pretty much like it has this, and then it has this. So it has like two parallel but opposite direction things, and it's kind of interesting, but they don't really like focus that much on it. Like this shape is even though it's like boring, seamounts are kind of boring, like in some ways boring, even though that like its shape is interesting and really makes seamounts more interesting by being so cool. East-west segments, okay, strike northeast, more or less parallel to large central Pacific fracture zones, such as the Mendocino Fracture Zone. Mendocino Fracture Zone is the boundary between the Philippines and Sulawesi and North Maluku Islands that were here. Central segment. Alright, wait, let me go. So it's parallel to it. I just wrote that down. I don't know what to make of it. It looks like as the dragon moved out through Baja and then up through here, underneath here, pretty much. Its nose generally went this way. This is the base of the Philippines. If we follow this, this does go to the Philippines. There. Kind of started an angle there. Just generally following this way, though. Without that angle. It does go to the Philippines. To the right side of the Philippines, too. And this one maybe has this here. Maybe this goes to, like, the... Generally... This is where the Philippines stop in this region, I believe. So it pretty much goes there. So this is probably related to the Philippines? Somehow? I mean, is that the right position? Right at the boundary. Let's see, does this node, if we follow this, generally go to that place I've been positioning? No. This one does. Oh. This one is this one here. Oh, there's freaking tracks the whole way? Oh my god. This one. Cross here to here. Incredible. It's just incredible. Let's see, what else do I got? Central segments, northwest, southeast, and then the other one, like that it's like this. I wrote, giving rise to speculation of the volcanic edifices below the mid-Pacific mountains. So they're assuming volcanic edifices. I have yet to see any evidence. Every time this comes up, it seems like just an assumption that's like searched for, but not actually like, here's the evidence kind of thing. That's just, obviously I'm just scratching the surface of this, but it seems similar to Hawaii, where we just assume, but the real source was elsewhere, just bringing material to a boundary that it was accumulating. Magnetic anomalies correspond with 120 to 153 million years. And then I got parts of the penetrated sedimentary columns are composed of sediments that contain a major portion of reworked material that has undergone vertical and or horizontal transports. Our understanding of the evolution of the depositional environments will therefore remain fragmentary because of the complexity of the sediment record. I'll look forward to finding some more information on this. I'm feeling at this point conclusively that this was forming exactly adjacent to United States, pretty much. The Rencha. adjacent to Laurentia in all of this, if put over here and interpreted in ways where the currents here are influencing the terrain here and the end resulting terrain here, that it will shed so much light on things. Where that was there, Papua New Guinea was down here, those islands were there, Philippines up here. Just it's crazy. Like it doesn't. That's the thing. Let me just give a little a little speech, a little pep talk or whatever. Like it doesn't have to match the age of this whatsoever. It doesn't have to. I was like, that takes that shape. It has the same length. It's a little too plausible and fitting everything else I know to not investigate further. And then I look and the age, the details, the question marks in science itself, and like the lack of any inkling of what might have actually happened. And then the details align. They're starting to just match. When I suppose something and I look, I'm like, oh damn, that fit. Telling. Nothing about me, but about this line of reasoning. That's all. Peace.